Using a given database, we want to conduct an appropriate hypothesis test at 7% significance level to determine the relationship between the given variables. Since the given variables are mixed, one of them is annual transportation expenses, which is quantitative, and the other one means of transportation or the types of transportation, which is qualitative. Finally, we will answer these questions or fill these parts, that the value of the test function, what's the value of test function here, and the critical value. We know that this type of hypothesis test is non-parametric, and usually it is right-tailed, and the critical value is going to be the upper critical value. Using the p-value, finally, we want to see that by what alpha significance level we can reject the zero hypothesis. What is the zero hypothesis? So, studying the relationship between variables, always zero hypothesis states that there is no relationship between them or they are independent. And we will reject the zero hypothesis if we can find some evidence that we can reject or that there is some relationship. So I just copy and paste this text from the question here, the variables transportation expense and the transportation mean. So we can say that the variables are independent. Or we can say that there is no relationship between them. And the alternative hypothesis, we say that they are not independent. Or there is a relationship between them. Now let's see what is the given database. So we have many columns here. Those which are important for us are column J and column K. I can hide the other columns or just copy and paste these two columns in a new sheet like this. I'm working with only these two, since we want to have some pivot tables maybe and extract the information from these two columns. So first of all, since I'm studying the means of transportation, I want to know how many different types of them are there, so we can use filtering. This is one way, but we can do or use the filter function directly instead. I will show that one. So if we put filter here, we will see that we have 1, 2, 3, 4 different types of transportation with bus, car, city public transport, and train. And also we can just filter for one of them and copy these data and paste in the new place that we need them. So instead of doing this, I remove the filter or clear the filter. And firstly, based on these two, so let me select two columns, only the headers, Control Shift and down arrow button. So already all the data are selected. And I want to insert a pivot table. Add existing worksheet somewhere here. So I need the means of transportation. I want to put it in the rows, and also the same thing for the values to see how many different type of transportational grouping we have, and also to make sure that we are using all the database in our columns that we are going to create for ANOVA. Now, right now I have this. We can select these values. And now in the here I paste them in as a transpose in rows. And let me highlight them. Now I want to bring all the data related to each type by using filter function. Now here I want to, first of all, let me select all these columns and say I want to have my data centered like this. Now here, I want to write equal filter. We'll write the function just once and copy it for the others instead of using different type of filtering. So what is the array that we want to use the filter? So the data are here. So these are my data. Control Shift down arrow button. However, I need only the first column because I need these values to be shown. So I select only the first column and I push F4 to lock it because if I copy this to the other columns, the column shouldn't move to the right. And the filter is like this. We filter based on the values in the next column. So to select these values, again, I start from the last row, Control Shift up arrow button, but I don't need the first one. So I want this again to be locked. No change here. It should be equal to the value that I have here in the top row equal to this one. So let me see what is missing. Oh, there is extra sheet name here, ANOVA. Yeah, that's it. We have all those data here. Now I can copy this to the right. Then we will see all the others already here. Now to make sure that we brought all the data here, if I use the ANOVA, then I will see the number of, for example, buses or cars or the others, and we can compare with this pivot table. And in total, we have 100 of them. Now, these are my data. And I want to use analysis of variance. So we go to data, data analysis. And this is ANOVA single factor. Where is the range? Already highlighted here, so I can select this part. And also keep the headers, and I will say that I have headers. So first, labels in first row, we have the data for groups in columns. And the significance level, it was given at 7%. Where do I want to put in a new worksheet, or here at the same place somewhere I will select a range. Not to overwrite the other data. Now we have our output here for the ANOVA single factor. And directly I can use the AutoSum to show that how many data we have, exactly 100. And this 20, 31, 16, 33 shows that we brought all these data by the filter function correctly. Now you can see that here we have the test function f, and this is the value for test function, but we need 2 decimal points, so let's keep only 2 decimal points for that. We pin this one, we need this, so only 2 decimal points. For the p-value we have this, for the critical value also we need that one. So we can see that test function is 99.36. The value of the test function is 99.36, and the critical value, which is the upper critical value, is 2.43. Significance level, since it is given in percentage, then I need to multiply by 100. So significance level here, this p-value is 2.5 times 10 to the minus 27, then it becomes minus 29, it becomes minus 27 if I want to write in percentage form. So this 2.5 times 10 to the minus 29. And we know that since it is one right tail test, then if significance level is larger than this value or greater than this value, then we will reject the zero hypothesis, or it shows that there is a relationship between these variables. So these are the values that you need to find based on the ANOVA. 99.36 for your value of the test function. Since it is in the, for sure we know that the critical value, upper critical value is 2.43, and this 99 is greater than that, and we reject the zero hypothesis, or it shows that there is a relationship between two variables.